welcome to another talk. We have an interesting talk coming up from Noah, Koshy, and Maulik on deterministic updates to improve the customer experience, to be running, I guess, edge devices?
In large numbers of Debian systems.
Okay,
wherever
large
they happen
numbers
to run.
of Debian devices, more deterministically, more reliably, and thus having a better customer experience. So please give them a warm round of applause. And if they are in time, we have the opportunity to ask questions after the talk, please.
Thank you. All right. Thank you. So what we're going to talk about today is a technique for ensuring quality when rolling out software updates, package updates, things like that, to a fleet of Debian systems. We'll get into when this is applicable, why this is applicable, what's interesting about it, things along those lines. So I'll introduce myself. My name is Noah. I've been a Debian developer for a very long time. I have been around since like the ELF transition. I remember all of this. I've been involved in a number of different aspects of the distro. I was on the security team for a little while. I've maintained a bunch of packages. In 2016, I helped found the current incarnation of the Debian Cloud team. So we sort of organized a group that was interested in running Debian in the cloud, ensuring that Debian was well supported and available everywhere, and that people who wanted to run Debian in a cloud environment were going to have a really good experience. So I've been working on that for a number of years since then. And then more recently, like in March of this year, I started working at Microsoft, where I'm focusing on ensuring that that Debian specifically is well supported in the Azure cloud environment, and that Azure sort of understands how Debian works, what Debian needs, and what Linux distributions and Linux users in general need in order to run effectively in a cloud environment.
Hi, my name is Koshy John. Thanks for having us here. I'm the technical lead for Linux patching in Azure. One of the products that I work on is called Azure Guest Patching Service, and we'll hear a little bit more about that in a few minutes. One of the components of the Azure Guest Patching Service is called the Linux Patch Extension. It's free and open source. Please feel free to check it out. A little bit of history. I've been at Microsoft 12 years now. 10 of those years have been around Windows and Linux patching at scale. So interestingly, while this is my first DebConf, the last DebConf was held in the city where I'm originally from, Kochi. One of the presenters is not here with us today because of logistical reasons, but I just want to quickly introduce him. Maulik Shah, he's the product manager for AZGPS. And as you can see, he's passionate about keeping workloads secure in Azure. So why is Microsoft here? I'm sure all of you are thinking this, and who let them in? So the background to that is Microsoft loves Linux, and this is not just a phrase. We truly love Linux, right? Debian users run on Azure, and we want to keep them more secure. We want to keep their workloads more available, as much available as possible. And Debian and cloud improvements are applicable to every Debian user, as you'll soon learn, no matter where they are. So let's talk about security versus availability and reliability. Usually when you say get secure, if you have a machine, it just means that you install all the latest patches as soon as they're available. Sounds good. But the thing is, that's only so good as long as nothing bad happens. And when something bad happens, unfortunately, as you might have recently seen, and if it happens at a global scale, it can cause a lot of pain, economic damage, and lost productivity. Right? And then the larger the fleet that you manage, the bigger the impact of this is. And this is especially true in Azure, where the managed size fleets are extremely large. So when you think about this, what do you mean we can have security and availability, right? So you have a system, you might have a fleet of your own. How would you manage to get availability up? You might say, okay, I would test all these patches on my machines extensively. I would have great monitoring, or I would have a lot of redundancy, or I would have great disaster recovery and planning and recovery procedures in place. But the thing is, when you look at it at scale, why all of these are absolutely necessary, but it's not sufficient to be secure, right, and available. So all of us know this, stage rollouts, right? You ensure that the rollouts go in phases so that the impact of something that goes wrong is restricted to a given region or phase or something like that. But this implies that you have to put in a lot of effort to get your systems in that shape and form. How can we make it so that it's available to everybody easily, right? How can it be democratized? And before we go to that, what does availability mean, right? You can have one machine and say, okay, if I install patches on it, will it remain up and running? Is that availability? That could be availability for you because you have one machine. What about if you have a global customer base and your machine's running around the world? What does availability mean then, right? And then when you go higher, like if you're a big company and you have thousands of machines, what does availability mean? How do you define what availability means in a way that a service provider would know, right? In Azure, these are some constructs that we have because we have things like update domains, fault domains. So it's more than just what your fleet says. So you have a sense of, okay, I have a database, I have a couple of machines as part of that set, and I cannot have all of them go down at the same time. So you define that in a way that makes sense and it's available to the provider. But there's more to that. You need to ensure that these machines are not sitting on the same rack. Because if power fails on a rack and all your machines are sitting on that rack, we cannot help keep them up. It's transparent to you, but that's something that we need to know, right? And what about maintenance windows? Maybe you're running a shopping site. You cannot have the shopping site go down on a Black Friday, right? So that's another thing. Now let's talk about safe deployment. One of the things that is required for a deployment of patches to be safe is that you need to have the payload that's deployed be consistent no matter what day you deploy it. If you are deploying something today and you're doing the same kind of deployment on a different set of machines 3 days from now, how confident are you that you're going to get the exact same patches? Right? That's one. And then these availability constructs that we talked about, they have to be respected because we cannot go and patch 3 of your database servers at the same time, right? So that's important. And what does health awareness mean? How do you know that your database is working? Suppose you're hosting databases. You probably have a probe, or you probably have something running in the background saying, okay, is my database still up? Is my database still up? Or is my website still up, right? So those are probes. So health awareness must be implicit. Maintenance windows, like we talked about, must be honored. These are the tenets that we work with. So I'm just going to give you a quick insight into Azure Guest Patching Service, which is what my team runs. And a little bit of background, so when Noah talks about this, it makes more sense. Azure Guest Patching Service is a unified platform for all first and third-party customers in Azure, which is completely free. And the importance of this is we are trying to ensure that everybody's fleet stays up because customer satisfaction is very important here, right? So there are a couple of tenets. Customer intent. How do I want to patch my machines? Resource actions. I want to go patch my machine now, right? Like think about this. You have a couple of machines. Maybe you can SSH into them and say, install all updates. But how do you do it at scale when your machine's sitting in some data center somewhere? Do you want to do that for 1,000 machines? You don't, right? So there are resource actions where you can do it at an API at the control plane, which is our surface for APIs like install patches, assist patches. And then we would do the orchestration for you, right? So I'm just going to go through all of these. So your customer intent would be OS control. That's what normally comes up, right? The OS gets a set of updates on a day, it just installs it. The issue with that is what we were talking about. If every machine around the world gets the same update at the same time and there's something wrong with it, everything goes down at the same time. And this has happened, unfortunately, too many times. And we have other options about, okay, patch by myself when I decide to, or on a schedule, or have Azure take care of it for you in a way that's safe. And we have coordination behind this, and we have reporting that you'll see in a bit. This is the very high level of it so that you don't have to individually manage machines. You can manage it at scale in a single pane of glass. And a little bit more about the Azure Guest Patching Service. The goal of our service is to ensure that there is no global blast failures as much as possible. We cannot have resources go down. We've been in the news. It doesn't matter if the update that caused an issue came from MySQL or anybody else. It doesn't matter. If it goes down, the first thing that people will say is Azure's gone down, or AWS has gone down, or Walmart has gone down, or any other customer or company has gone down. Right? So we provide this unified orchestration platform where we ensure that everybody gets the best-in-class patching capabilities, no matter how big or how small their fleet is or how knowledgeable they are about patching and staying secure. We just make it easy. Which brings us to an important point, right? So safe deployment, when we install updates inside a box, requires the operating system or the repository to support this capability. Historically, when we first started this, Windows has this capability because all the updates that go into Windows have a date associated with it. So you're able to address which package was available on which date. Linux did not have a scalable equivalent for the longest time. There's an asterisk there because we've done something about this, but I'll let Noah continue. Go ahead.
Thank you. Yeah, so regardless of what you're using for an orchestration mechanism for rolling out your updates, those updated packages need to come from somewhere. And so I'm going to talk about how you can build a locally managed archive mirror that implements some additional features beyond what are available today in the standard Debian mirror system that help to support deployment safety for when updating a large fleet of Debian systems. So we're going to dig into this a little bit, what do I mean by when I talk about deployment safety at scale, and what do I talk about? What I mean when we're talking about deployment safety? So by scale, what we're really talking about is a large fleet of basically the same system. So this is a fairly common cloud deployment pattern. It's not unique to the cloud by any means. These can be bare metal hosts that are provisioned in a data center using an automated installer like FAI or something along those lines. They can be cloud systems. They can be any other sort of Debian system. But that is it's big. They're maybe hundreds, thousands of systems. They're intended to all be the same. They're all running the same application, and you're managing them using some system. Whether this is this could be Ansible, Puppet, things along those lines. And we need to update them safely when a security update becomes available or something along those lines. So, what does that mean, like by safety? One of the things that has been observed by Microsoft and by others in the industry is that most availability issues are actually caused by deployments. Like there's a change that was intended to be pushed out. It was introducing a new feature, introducing a security update, something along those lines, and some regression snuck in and actually caused production impact. This wasn't anything malicious. It was an accident. That's what causes most service impact in real life. And so when we're building our own software, our application software, that sort of thing, we typically see, we deploy that using a common pattern involving pipelines that run some tests before deploying. If any of these tests fail, we abort that deployment. If the tests all pass, we may move to deploying to a pre-production staging environment, something along those lines. If those tests all pass, then we might start doing a phased rollout to our production environment, all of that sort of stuff. So eventually, we've deployed to our worldwide fleet, and we've done so very carefully, very deliberately, and taking steps to ensure safety along the way. We don't always do that with operating system updates, though. So when we want to roll out a security patch, we still need to pay attention to the impact that it might have on our fleet. We need control over that same sort of, we want the same sort of control over the rollout process of a security update. And the current Debian archive doesn't really support that. We don't control when packages enter the Debian archive as sort of fleet owners, as people that are running a production environment that's based on Debian. And what I mean by that is, today's dist upgrade might produce different results from yesterday's dist upgrade without any other changes to our system at all, because, say, a new package version, a DSA was released, and a new package version was entered into the security archive. That changes the behavior of the dist upgrade process that runs on our systems. So that's unsafe. That's something that we actually need to take care of and sort of control for. We can do that we can try to do that by pinning to specific versions and say, I want to update bind 9 to this new version because there was a DSA that was just released in bind. But that's not ideal either, because one of the things that we do in the security archive is we delete old packages in order to save space on the mirror network and that kind of thing. So again, a dist upgrade or an upgrade to a given version of bind may not work because the package may not exist anymore because it's been superseded by something newer. So we do have a system that's potentially interesting here, which is snapshot.debian.org. It provides what it describes as a wayback machine for the archive. So it gives you the ability to specify a timestamp and say, I want to refer to the Debian package repository as it existed on this date and time. That sounds pretty promising. It supports all of the archive sections. It supports security. It supports stable updates. It supports backports even. It supports SID and testing, and all the different parts of Debian are supported by this. And it's used elsewhere. We heard earlier today about how it's used by the reproducible build process. We also know that it's used in building the Debian container images so that they can build reproducible container images. So, like, Snapshot is a pretty good system. But it's not entirely suitable for what we're trying to do here. If you've ever used it, it's very slow. There's one system in one data center, and access to the system from different points around the world is not very fast. You can sort of deal with this. You can run a caching proxy or something along those lines, and it gives you it lets you address the download performance. But it's still a single point of failure. And we don't really like that. That, again, is a risk for our deployment safety concerns. We'd like, ideally, to be able to mirror it locally, but that's not really practical either. It's gigantic. It contains basically every version of every Debian package going back to 2004. Even if we could sync all of that content, serving that content, the way the system is architected right now, requires intelligent remapping. There's a database involved. There's intelligence in the serving process. So it's still awkward to try and mirror. I've worked with the Snapshot team a little bit. We have discussed how mirroring could work. There are other people interested as well. So we may be able to address this. And that might help a little bit with this next point as well, which is that it's not really intended to point large fleets of systems at. It's fronted by a CDN, which should give it the ability to cope with load, but from a practical perspective, most accesses end up being cache misses at the CDN and still go back to this single point of failure. So it's still got problems. And then even if we addressed all of those sort of operational issues, fundamentally it's got this one weird issue where the timestamps that you refer to, you can essentially make up any arbitrary timestamp. I can give it a timestamp of midnight of last week or something, of Monday of last week, and that will get resolved to the nearest actual snapshot that exists at that time. But that's not actually deterministic, because that can change. An example of how this might manifest itself, there was a time when snapshot.debian.org was not getting any updates. It was not creating new snapshots during this big hardware migration that just completed recently. Through the month of June, it was not creating any new snapshots at all. So I could refer to a snapshot called 2024 06 15 000 and say that's my June 15th snapshot. But that would have still been mapped to the snapshot from May 31st, because that was the last one that was made. Until at some point, all those snapshots, the hardware migration completed, and all of those snapshots were backfilled, and suddenly there was a snapshot on June 15th. And so suddenly, those things, those client hosts that were referring to the June 15th snapshot are seeing 2 more weeks of package updates. So again, that's not deterministic behavior. That's a problem for us. So another thing we can consider is hosting our own snapshot-like service. And it turns out that this might actually be practical. We can do it in a way that's much smaller than a full mirror of snapshot.debian.org. We don't care about all the packages going back to 2004. We really only care about the releases that we're running right now, so the releases that are on the main archive network right now. We also don't care about all the architectures. We mostly probably, if we're running a production system on a large fleet, we're probably running AMD 64 or ARM 64. So we can leave out most of the other architectures. We can also probably garbage collect old snapshots if we really care about space, so we can get rid of a lot of overhead that way. And so using something like this, we can actually address most of our requirements for deployment safety in a Debian mirror. And the cool thing is we can actually do this mostly with just some small modifications to the current FTP sync scripts. So I've been calling this system Snapshot Lite because it is a much lighter weight version of a snapshot-like service. So it runs like a standard mirror. It pulls content from an upstream rsync server. One of the differences is we don't delete packages, so we just keep all of the pool content growing over time. And then the repo metadata, when it gets updated, it gets snapshotted, and so that's what gives us our sort of point-in-time views into the Debian archive. And then we can use a simple URI remapping scheme, so we don't need to do individual URI lookups based on a database or something like that. We can just have a simple redirect rule in our web server. So let's review a little bit of the structure of a Debian repository, because the details of this sort of dictate how we need to cope with these operational details in our snapshotting process. So a Debian repository is self-contained within a directory. That directory is typically mapped to /Debian on a web server. And then there are content in subdirectories there. The /pool directory contains the actual package contents, so the deb packages and the source packages. And there's a dists subdirectory that contains the repository metadata. So we're going to be mirroring all of that from our upstream. The pool directory is mirrored just by adding new packages or new files that represent new package versions. And then upstream, if there's a package removal, that's just a file removal from the mirrors. Existing files within the pool directory, for the most part, are not overwritten. So to support snapshots of this, all we really do is skip the removal step, and we just keep growing this, so we don't ever actually delete old packages. And then the dists directory, this is a little bit more complicated because the big difference here is that files are overwritten in place. This is the metadata. This is what refers to the this is what describes the repository and all of its contents. So this is what we need to snapshot whenever it changes. So in order to support this, this snapshot light service, what we want to do is whenever we get a change, we want to create an immutable snapshot. And whenever we do this, we also want to snapshot all of the archives. And the reason that we want to do this is because we're not doing this dynamic generation of the dynamic mapping of timestamps to a particular snapshot. We have a discrete list of snapshots, and we list each one of them, and we want them to be the same. So if the Debian security archive changes and we create a new snapshot, valid for all of the snapshots or all of the other archives as well. That's a pretty straightforward thing to do. All we need to do is create a symlink in the file system for a snapshot that is unchanged from a previous snapshot. And so we give each one of these snapshots a timestamp, and this timestamp exists in the file system. So this is going to be something that is in the file system. It's in a directory tree, and the web server can point directly to a Debian directory within this snapshot, and so you can point your clients at it. Creating this snapshot is a fairly straightforward thing to do. If we want to, the most minimal way of doing it is that we just copy it. It's 20 gigabytes, so when we get an update from our upstream mirror, when that rsync completes, we just copy that to a new time-stamped location, and there's our snapshot. And that might work. If you have enough disk space and you can handle creating a 20 gigabyte directory every day or so, you can definitely do that. But without a whole lot more complexity, you can actually save quite a lot of disk space by using things like rsync with linkdest, which lets you deduplicate content if things haven't changed when you're creating your snapshots. It just creates a bunch of hard links between directories, between files that are unchanged within these directories. You could also use block level deduplication and get even more efficiency. So snapshotting this is not super difficult. Serving this is also not super difficult. So when we're serving a given package or a given repository, this looks on the web server like some stuff ahead of the Debian directory in the URI path. So this is very similar to what you're going to see if you're working with snapshots on snapshot.debian.org. It's just on a different service here. And then we can actually make all of this work, make the pool access work by with a simple rewrite rule. This is in an Nginx configuration sample here, and what it's doing is anything that tries to access the pool directory, subdirectory of any snapshotted Debian directory, it just gets remapped to the top level shared pool directory that we've been accumulating new packages in all along. And then to tell apt about this, to tell clients how to find this, we've actually got a couple of different things. So apt introduced, this is the, in Bookworm, we can use, and earlier, we just reconfigure the sources.list or the Debian.sources file to refer to a specific snapshot. So here, instead of saying, pointing to deb.debian.org/Debian, we point to our snapshot service and the snapshotted /Debian location. And so at this point, apt will retrieve that particular snapshot version of the repository. And it will see packages from, in this case, July 9th. And this is compatible basically with every version of apt that it exists. There's also apt added native snapshot support with 2.7. We're on 2.9 point something now. So this is available in Trixie and newer. So apt actually knows about snapshots now, and it has a number of different configuration options and command line flags for interacting with snapshots. So we'll talk a little bit about how we can configure a newer version of apt to know natively about our snapshot service. So apt today knows about snapshot.debian.org specifically. It has this information hard-coded in it, so we need to override it and tell it that our snapshot service should be used instead of the hard-coded version. And so this shows how to do this. The labels come from the releases file, and we're just telling it to use use our service for snapshots for repositories with a given label. And you can see this magic @snapshot ID keyword that gets substituted with the actual snapshot version that's specified. That can be given to apt either in a configuration file, or it can be given on the command line. When overriding like this, there is a bug in apt right now, and that basically means you need to do, when you're overriding its built-in snapshot knowledge, you need to run apt update twice, because the first time it doesn't have any metadata to override, and so it's going to try to reach out and talk to snapshot.debian.org, and then it finds all of the metadata, and then you run an update again, and it knows where to apply the overrides. So at some point, I think we'll try to get that fixed. But and so putting this all together into a concrete example. Here's how we might just, this is a container. This is how we might build a container image that is using a specific version of the repository. So this is copying a sources file and an apt config file into place, then running apt update and then installing a few packages. And you can actually see here that I'm working around that bug that I mentioned. There's the run apt-get update, and then later doing run apt-get update again after installing the overrides. That's because we need to install, we need to have metadata in place before we can, before the overrides will get applied. And the apt config, this is installed in etc apt.conf.d. This provides the overrides, and it provides a default snapshot that we're going to use. So this will be the July 23rd snapshot, and that's going to get substituted into the snapshot ID field in these URIs when doing an apt update. And the sources file doesn't need any real changes, except very similar to when we're working with snapshot.debian.org. We need to disable the support for the expiration in the releases file if we want to be able to pull content from older snapshots. I think the security archive has like a 10-day validity for the releases file or something along those lines. So if we want to pull something that's older than 10 days, we need to disable that check. So that's the last line on each of these entries here, the check valid until no. That's the only change that we need, because otherwise apt knows all about how to talk to snapshot services. And then, so from that given Docker file example, if we run a Docker build or a Podman build, we can see this is a truncated output, but we see, among other things, that we've got the apt update and the apt install, and then we're downloading the metadata, and then we're installing packages from that snapshot. And this all happens, and it's going to happen the exact same way, regardless of whether you know where and when and how you run this. So you're getting the exact same package versions. So when you build a container image like this, if you are then deploying that container image into production, or you are you're using that as a base layer for subsequent container image builds, all of those containers, all of those uses of this image are going to get the exact same set of packages because they're going to see the exact same repository version, and you have complete control over when updates to that to these containers are made available. So, in summary here, if we want to support deployment safety, when updating packages, we need repeatable package operations. We need them to be reproducible. We can make that happen using immutable repositories. And that's what we've created with this snapshot service by snapshotting the repository state. And we can create that pretty easily by just copying the dist directories into our timestamp locations and updating the pool content. So it's a pretty straightforward change to how we're normally mirroring Debian in general. And then we've got a demo using the guest patching service to orchestrate the same sort of stuff. This was done using Ubuntu. Sorry, can we stop this now? So this was done using Ubuntu because Ubuntu, Azure added direct support, native support for Ubuntu late last year, and this video and this demo was shown at the Ubuntu Summit, I think in November of last year, and this is exactly the sort of thing that we're working on building for Debian today, and this is going to be added in the near future. So we can show an end-to-end demo here in this video.
Can you check if you have audio?
Let's walk through the creation flow of an Ubuntu machine in the Azure portal. Right. In this create of your virtual machine flow, there is a tab here for management. In here, there is a guest OS update section where there are two options. Image default, which is whatever the operating system comes with, and then there's Azure Orchestrated, which is provided by EasyGPS. This is where the magic happens. That one setting changes everything. We go from OS control, unmanaged, uncoordinated updates to Azure control, globally coordinated updates that respect Azure constructs like availability sets, availability zones, update domains, and customer-defined maintenance windows. We have health awareness at scale, fleet clarity, both for the customer and for Azure as to what's happening. And in an important distinction, we are able to ensure that these machines are secure with the reboots where required. So what does this mean in terms of a consumption experience? Let me show you how this looks in Azure Update Manager. Right, so here's a machine that I previously provisioned, and as you can see, safe deployment has automatically taken care of clean security updates to the last known good state. You can go over to the history tab where you can see the list of operations that happen on this machine. Let's look at this one. Right, so this was an Azure managed safe deployment. We installed security updates up to the watermark that was necessary for the region. A reboot was required, and we completed it.
Okay, and So right now, what I've described right now is sort of intended as being something that anybody can run as part of their own locally managed package mirror. It's nice in that you can also add support for your own package repositories if you have internal packages that you build and use. We're also thinking about building this and offering this sort of thing as a public feature of the mirror that runs in Azure. So that's something that could be available to anybody. So if that's something that's at all interesting to people, definitely talk to me. I'd like to hear use cases for it. I'd like to hear if there is interest and that sort of thing, because this is something that I think is a really powerful and useful thing to allow you to control exactly what you're getting on your systems at any given time. And from if you're running at scale and you want to make sure that you're not getting surprised by package changes in the repositories and things like that, this can be really useful. So love to hear from you if you're interested in it. And at that point, if anybody has questions or anything like that, we've got, I think, a couple of minutes, or you can come and talk to myself or Koshy anytime. Come to the CloudBoff on Friday. We'll have discussions there. I'd like to hear, get feedback and things like that on the idea and that sort of thing.
Thank you.
Thank you very much, folks. Thank you for sponsoring DebConf still. If 2 out of 3 can fly, we're still happy with the money that Microsoft can forward to us. Do you have any questions to those gentlemen here? Please, wait for a microphone if somebody has one. Do I need to run?
Yeah, your microphone.
Okay, Jonathan's coming with a microphone. He thought he could delegate that job to me. That didn't work. And please stand up because the camera loves to see you.
Hello, I have 2 questions. The first one is about the hard linking the files in the this directory. As far as I may know, we have acquired by hash in Debian repo. So the only file that is immutable is the in-release file, and all other files in this directory is also immutable. So I don't think there any need to hard linking the files in this directory.
The files in the by hash directory are cumulative, and so new files get added to that. That's exactly where hard linking helps, because we don't duplicate any of that content when we make a copy.
Okay, the second one is, have you ever considered to utilize file system level snapshotting, for example, the snapshotting in BTRFS or ZFS?
Yeah, so one of my coworkers actually set up ButterFS with the bees extension for doing like compressed block level deduping, and it definitely added additional efficiency. So it is useful and it does work. I found that the rsync based hard link solution was trivial. It was very easy to do, but I think ButterFS is also not that difficult to set up. So it does require a specific file system in order to work and that kind of thing. So not everybody is necessarily hosting their mirrors on a ButterFS file system, but you can. Yeah.
Okay, thank you.
What was the question there?
Okay, I want to ask if it's in the right
Put the
place.
microphone more in front to your mouth, please.
I have one question. I'm not sure if this is the right place to ask about the mirror snapshot service. Do you consider how downstream or Debian derivatives to pick up this apt snapshot mechanism?
I am not sure I caught the question. Sorry. You can repeat it, or we can talk in person if you want.
I think the question was whether downstream distros can use this. Is that Did I get that correctly? Okay, so whether downstream distros could be kind of tenants on your service.
I think so. I mean, you're talking specifically about deriving from a specific snapshot, or are you talking specifically about using the same technique within a downstream distro?
Using the same technique.
Okay, yeah. So it's if your content can be rsync, can be mirrored the same way that the current Debian mirroring scripts work, then yes, like conceptually, it should work for anything.
Are you asking about Debian? Which distro are you interested in?
I work in this Debian, but I don't mean specifically in Debian.
Okay, thank you. Okay, Jonathan shows the magic. We've run out of time. Noah, Koshy, thank you so much for your talk. And you're around for the rest of the conference, so people can hunt you down for more questions? Yep. Okay, wonderful. And please get them off the stage with a warm round of applause.
Thank you.